Hi everyone, Mr. Eder here again. This is the last lab of the semester. We look forward to doing more of them in the second semester. But on this one, it is the empirical formula of iron oxide. So your goal is to use data to determine the empirical formula of an iron oxide compound. You will start off the lab with the pre-lab questions. There are 2 of them. Use the information in the problem to calculate the formulas in number 1 and number 2. Once you make your submission, you can submit your answers and lock the answers to access part 2. So part 2 is the experiment. Here you will watch the video about how the iron oxide mass is found and how the reaction occurs. So there's steel wool, which is mostly iron, but not all iron, but mostly iron. And you can see the mass over here of the steel wool. And then through a spark will be reacted with oxygen in the air, and you will make your observations about the mass and what's happening to the steel wool and the oxygen to produce the iron oxide. The problems then step out the initial mass of iron. It steps out how to solve this. So I know that in class you've probably worked through many of these problems kind of all together. This makes you stop every step of the way. So just be careful there and make sure you're answering the question that is actually being asked. And so it does make you step out your work along the way. So how many moles of iron are there? What mass of iron oxide product? So at the end, what's the final mass? What is the mass of oxygen bonded to the iron? So how much mass of oxygen is there attached to the iron? And so that would be taking the final mass minus the initial mass of the iron, because any mass that was increased would be due to oxygen bonding to the iron. Calculate how many moles of oxygen there were. And from that, using the moles of iron and the moles of oxygen, calculate the empirical formula for the iron oxide. Once you know the empirical formula, you can then answer question 9, the charge on the iron. So you know that the charge on oxygen is always -2. So from this, you could figure out what the charge on the iron atom is, on each iron atom. When you lock your answers and continue, go on to the analysis, and it asks you to analyze your data. 2 questions here. I want you to think about those for yourself. Again, as always, let your instructor know if you have any questions.